I was asked to step in at the last minute for Sergio, who's has a family member who's not well. And in the short space of time, it seemed sensible to pick on a piece of work that I've been doing recently, which is a topic of this, which is to look at ontologization practices. Um, it's written, the work was done with other people, with Andrew Mitchell, who works for BORO. I've been working with a long time. Sergio is at University of Westminster. We've been working a long time. And John Beverley at University of Buffalo, who well, this is probably one of the first things we've done together, but we've known each other for a little while now. Um, the this is the presentation is very similar to one that I did at a conference that John organized in the States, the STIDS conference, and I'm not sure that in the time frame I'll be able to cover it all. I think that STIDS was similarly short, and I managed to do quite a lot, but maybe I should go a bit slower for this particular audience. So I'm imagining that I'll do the first three items and this maybe not have a chance to do the last two or three items on there. I mean, the last two before the summary, and maybe I'll jump across the bottom two and then go towards the summary. The key message I think I would like to do in the space that I've got here is to just suggest that we should maybe rethink about how we address the ontologization process. And I think that there has been, it's been as a result of various historical reasons, or one can speculate on why. I think it's had a rather a narrow outlook, and I'd like to suggest that it's wider. I'm going to try and explain what I think the narrowness of the outlook is, and where there is space in the design space or opportunities in the design space for doing something differently. There's going to be a few thoughts on how we should try and address that space. And then I'd also like to if we've got time, just quickly to look at a process that we tend to use in our work, a process, or bCLEARer, where we focus on the ontologization. And in a sense, that's a motivator for this, because we've been, if you like, exploiting this area of the design space that other people haven't, and we're a bit surprised, if you like, looking back, that people haven't done it. There's another general theme, which, if you're interested in, probably the best way is to go to the paper. If you want a copy of the paper, email, I'm sure the organizers or me, or we can share the paper, which is trying to give if you like, a bigger justification about what shape the ontologization should have. And I'm developing an outlook which tries to put it in an evolutionary context, or first of all, a digitalization context, then put digitalization in the evolutionary context. But I don't think we'll have time for that today. I've tried to simplify the issues, and as always, when you simplify, you end up oversimplifying, I think, or almost always you end up oversimplifying. So I'm suggesting that if we look at if we want to look at ontologization, one way is to put a two-dimensional framework on it, with one of the dimensions being level of generality and the other being level of digitalization. And that gives you this two-dimensional grid, and you can position the ontologization process in this grid, and you can see which squares are used and which squares aren't used. And then as a result, you could see where the opportunities, where there's space that hasn't been exploited or isn't used, and the potential for doing exploitation. Let me explain a little bit about what the two items are. So the first, levels of generality. Syntactically, it's easier to see it. So there's the three levels. Three is a nice, easy number. I mean, you could divide it in different ways if you wanted. Is metadata, schema, and data. The schema would be, if you think of a relational database, would be things like the particular tables and column headings you have. So you might have a client table. It might have a column called column name. The data would be the rows on the table. So there could be a row that says, under client name, it's got Chris Partridge, and under client address, it's got London or whatever. The metadata will give you the overall structure. It would say things like there are databases, and databases contain tables, and tables contain columns, and columns have column headings, and so forth. if you're coming from an ontology point of view, you would say, oh, I want to have a more sort of one that's more in tune with ontologies and maybe top ontologies, and you want to have a more semantic classification. You just want to say at the very top, they're very general notions, which are categories. In the middle, they're sort of domain, universals, and types. And at the bottom level, you've got something like particulars. The issue for this is when we come to look at the ontologization process, is I'm suggesting that when we start the ontologization process, we don't have access to these ontological type classifications. And particularly if we start with computer data, we do have access to the metadata. And then the next bit of the next dimension is the levels of digitalization. And I've done quite a lot of work over this for, I don't know, actually since I started, I've always seen that the shift from, or the requirements for ontologies being part and parcel of the shift from a literate or a printing type civilization into a computing civilization, and the shift requiring new tools, including top ontologies. In this, I've tried to lay out, at least as from a human perspective, though you can actually go back across the whole of evolution and see it in informational terms, just the various stages. So obviously there was a stage before speech. Speech came along. Writing we're more familiar with because writing leaves a record, so 9th century BC. Printing for Western Europe, middle of the 15th century, and then computing, depending on where you think about it, somewhere around the middle of the 20th century. So there have been a series of shifts, and associated with these shifts is the way in which you store information. So the previous stage evolutionary steps are still around. We still store information in our brains. We still talk. We still, well, some of us still write. They're still printing. And we also have information at a computing level. And the final bit of the toolkit that I'd like to put in here is the notion of an information pathway. So if we step and look at the process of ontologization, the methodology that we follow through, at the end we'll have a deliverable, which is a piece of information. At the beginning, we may start with information we may generate it over the process, but there'll be a pathway as the information evolves through the methodology. Again, what I'm in a sense, I'm looking ahead here. What I'm going to try and argue is that if we do take this two-dimensional design space, that this the data space and the computer space is less exploited than it should be. So, and hopefully it'll be a result, if you like, if as a result of my talk, you think about changing your practices to maybe start thinking about how you might exploit these two particular spaces. If you talk to data engineers and so forth, people who work with data a lot, people who work with data pipelines, and also people who also do some work in systems development, there is a notion of shift left, the idea of moving things that you normally do towards where right and left are the timeline on a project plan, where you move things that you normally do at the end of your project to the beginning of the project. And in a sense, this is a shift left story by saying that there are some things that by leaving to the end, you're not getting the opportunities that you would have if you looked at them at the beginning. If you want to check out some more details of this from other disciplinary areas, particularly sort of data engineering and so forth, there are some links at the bottom. In this kind of exercise, you need in a sense, a straw man. The situation is often far more complex than can be easily represented, particularly in the short period of time. And I've chosen these two approaches just to make clear is that they've been set up and, in a sense, simplified in order to make a point. And the claim is not that this is all practices fall under these two things, but I think it'd be a fair comment to say that many mainstream practices fall roughly under one of these two ways of doing things. So these are probably reasonable representatives of the broad structure in terms of the way people approach ontologization. The first one is an OntoCommons report, methodological framework for ontology management. I think it's actually a really, really good report. It does a very good review of the various sources and does the harmonization. It attempts to take the best from each of them into its own new methodology, which I'm trying to remember, maybe because it's the first one on there, it's probably called LOT. Apologies for not remembering. and this, as you go through, particularly as you read the text, you see it's a good example of an ask an expert, and you'll see hopefully as you go to the next few slides why I make this as a characterization. The other one is another one is you're probably familiar with, is one from BFO, which is Barry and his colleagues wrote. It's a really good, clear example of the approach. You can see it's got a slightly different structure. It has more clear roots in biological classification and philosophy, and it's more attuned to the notion of having a top ontology. That the ask, as we'll see in a second, the ask an expert avoids the issue of the top of using a top ontology. So start with the ask an expert. So one of the things that if you do the kind of work I do a lot of work with commercial systems and mining ontologies from existing commercial systems, is that it seems to be an armchair exercise, in the sense something that you could do in a meeting room rather than going out and wrestling with the data out there to try and extract the ontology for it. I'm just trying to, where are we? So if we see for the first quote, so based on the ontological requirements identified by the domain experts. So if you think again, if you go back in terms of the stages of evolution, you're finding the ontological requirements from conversations with the domain experts. So it's a combination of brain and speech in terms of evolution. Maybe there's something writing down that you can take for, but there seems to be this focus on actually, if you like, trying to extract information from people's brains rather than from what's written down, or rather than from the computer systems. There's the way of formalizing it seems to be, at least early in the process, as you write the requirements in the form of natural language. So there is a preference from natural language over formal language. And there's a note here, there's this revealing comment about you can use pen and paper or a blackboard. So again, in terms of the, if you want to think of the stage of information evolution, it's sort of at the brain writing, pen and paper type level, not even sort of the printing or the computing level. So again, if you look at the processes where you go through, because the end result tends to be a formalization of some kind, and presumably a formalization that I don't think they necessarily say it, the one that ends up on a computer. So if you look at it from the level of generality, it sticks with the schema. As I said before, it avoids the metadata and also avoids data. And as it goes along the process, it's only at the tail end of the process that you get anywhere near computing. So if we look at the exploited and the unexploited in terms of the two-dimensional matrix that we've shown here, is that it sort of works certainly for the early stages, and this is, we're looking at these stages here, which is what this line is meant to say. It doesn't involve the data, it doesn't involve computing, and it doesn't involve metadata or a higher level. If we then move to the top-down classification, this here is a copy of a table from this, which helpfully outlines the steps to be followed when designing a domain ontology. And again, you'll notice steps 1 to 4 again are in this in terms of information evolution, or in this pre-computer stage. It's only at the very end that you computerize. And again, that there is this focus on human experts in the corresponding discipline. So the source material tends to be, there's a feeling is that, the standard terminology in play, they may be written down, but there's also this notion of human experts, so that one's taking it from brains and so forth. This is just a side slide here, is that, if, in a sense, reflecting this issue about data, if we take this ISO standard on ontologies here, one of the things that you notice is that it seems to quite deliberately diminish the role of particulars or data. I remember when it was actually being produced, I discussed this with both Matthew and Barry about doing this, and so I said it was very odd. I think in the early version, I don't even think they had distinguished particulars, but there doesn't seem to be any desire to allow data into these ontologies. So if we go back here, we've got the same thing. This tendency to exclude data, focus on schema. given that it's from BFO, there is this interest in metadata. It's difficult to tell, but almost from the beginning, there is a talk about how it'll fit it, having a concern about how it'll fit in the top level categories. But again, if you think from a level of digitalization point of view, it's only towards the tail end that you look at getting the information pathway to be used on a computer. And here again, you see the space that's unexploited here. So if we look at the comparison, so level of digitalization, we see this thing is that, so as I said before, we shift left. This is a very much, you shift the computer to the right, you want to shift it to the left. And if you go back here, is that it's not even a shift left, if you like. It's data's completely excluded from the process. Just a quick sort of background. I work with a top ontology called BORO, which some of you should know. Hopefully you do know. It was developed in the late 1980s, and it particularly looking at something that involved computing and a legacy re-engineering process. So it was legacy system modernization. So you had an existing system, which had its data, so it was in a computer system, and you had to translate that from one computer system to another computer system. So the whole process was inside from a level of information evolution was completely inside the computing space. Let's see what's happening here. Okay. Yes, also that there was a strong focus, I think, which Laura mentioned at the beginning, is that we're focusing on commercial projects rather than academic ones. We have two processes. There were two components right from the very beginning: the top-down ontology and this bCLEARer bottom-up framework. And I think that it'd be fair to say is that of all the various things out there, one of the things that maybe differentiates this particular top ontology is that it has as much focus, if you like, on the methodology for developing the way the ontology comes together as the top ontology itself. Just to give you some idea, is that in terms of the way it's been employed, this is giving you some idea of. I probably don't have time to go through all the different ways in which the bCLEARer process can be used and the top ontology deployed in various different projects. This is a picture we often use for describing. We start with a system here. It goes through a series of clearing processes. So we have a shared model and we've got a clean model after. Maybe, yeah, it's got a series of stages here, which we've divided up. And the idea is that you go through iteratively, you go through all of these stages, and you basically enhance and build up your foundational ontology, which you then reuse. So it's a scalable way to systematically improve the semantic maturity of systems. Again, this is another picture. What's interesting about this is that the idea is you have multiple systems working together, from which you extract a single ontology, and then you deploy it across multiple systems. And this has obvious implications for semantic interoperability if their data structures come from a single ontology. How much time do I have left, Frank? Are we?
You're approaching the 5-minute warning in 2 minutes.
Okay, that's good. So again, the other thing that's interesting about this is that the bCLEARer system has a series of stages, as you can see here, before you get to this top level ontology. And if I go back, you can actually run bCLEARer without running the top ontology. You can do various things. You can actually do your improvements through the ontologization process without doing without getting to a top ontology. And then what I'd like to claim, and you could guess that I was going to claim it because in the sense that I'm trying to showcase bCLEARer, what it does is that it basically occupies the design space for exploitation, the particular framework that I've chosen. I'm sure if you were so minded, you could design a framework such that any one of these things appeared in a certain way. But the point that I'm trying to make is that the issue is that about the inclusion of data and about the level of digitalization, and this particular framework highlights that structure. one of the things when I was looking at this, and so one of the surprising issues for me is the lack of investment that there has been, or the lack of attention there's been on, if you like, the ontologization process and the design of it. There is some there. I'm not trying to say there isn't any, but if you compare the depth of work done on the product, if you like, which is the top ontology, and compare it with the process, there seems to be an imbalance. I mean, one of the ironies is that if you go to the standard here and you look at the for process, it gives you an ontology of processes, but it makes no mention of the ontologization process itself. And you could say that's fine, it's not meant to standardize this, but where is the standard for this? And I think that's that is, if you a reflection of the interests of the people who are involved in this and if you like, of this work. The other thing is that if you come from, I do a lot of work with engineers in because of the commercial applications that I work at, and one of the things they're very conscious of is that you engineer the process as well as the product, and it's equally important, if not more important, to engineer the process than engineer the product, because the quality of the processes determines the quality of the product. And there's a whole lot of literature if you go and you look at on engineering a process on this. So the idea here is that if you can specify exactly what you want your cup of coffee, but if you don't specify how you're going to grind or how you're going to brew it or what the input is, your chances of getting a good cup of coffee are reduced, so we say.
Now 4 minutes left.
Sorry?
4 minutes left
Oh,
now.
okay, that's perfect. Okay, so the just to say that, of course, there's more than just product and process. You've got you might be familiar with the value chain from Porter. There's all these other things as well, but I think process is a central and core part of what's going on. One of the other things that when we looked at the bCLEARer work, and again now we're trying to do our initial engineering of the process, is that we found that it made sense to divide the consumption of the data into two parts. So into a computerization part where you basically on the computer system made sure that you had all the data you want in the form that you wanted before you started to try and do your ontologization. So if you think about it, this is almost the opposite is not quite the word. It's completely different from the way the other processes do, which is where you sort out the ontologization in your head, but and then you start computerizing it. And within the computerization process, we made for a surface computerization, computerization, which is where you ensure that the data is structured, and then something we call deep computerization, where just in the context of that computer system, you're trying to make all the implicit syntax clear and stuff. And this would include things like data cleansing and so forth. So this is, if you like, a proposal for if you were going to have your ontologization process more computerized, how you might segment it up. And this is just trying to give you some idea about how you can work out the process. So, and you can see the big difference here is that you do in the bCLEARer pipeline, you get the computerization stuff done first, and then you do ontologization, whereas it looks to some extent you go the opposite way in terms of if you just look at the documentation of the methodologies for the two processes we looked at. Okay. I'm trying to think why this is a Quine quote. I'm trying to think where it came from. I've forgotten why that was in there. So I'll do, okay, so this is an accounting example, which I'll try and explain in a few seconds. So one of the issues, if you go back to Pacioli, is you have debits or credits. And I think unless you actually start running with data, one of the things you don't realize is that the debits and credits of the two parties are going the opposite direction. So for Pacioli, he's making a purchase from Ruffin, and Ruffin is making a sale to Pacioli, and that whether you're a counterparty or not depends on it. So you've got a day say or a view from somewhere. So this is the view from Pacioli, this is the view from Ruffin, and in a sense, if you're doing ontology, in a sense, you want it from nowhere. Now, one of the things that I would argue if I had more time is that if you don't have data, it's very difficult to realize that you've got this DSA in place. I'm trying to think here. And what happens is, and this actually cashes out when you look at the data, if you've got where you have multi-company accounting and you've got two subsidiaries, and the subsidiaries have payments that go one to the other, when you try and consolidate for the parent company, there are well-known issues on that. And you can see if you go back to this thing here is that if this one is regarded as a purchase, this one's regarded as a sale, but it's the same transaction, you're going to have difficulties when you try and reconcile them. And the difficulties, I think the difficulties are difficult to spot unless you're working with data. Right, so let's go forward.
Last minute, Chris.
Okay, so I'll zoom off to the summary here. There we go. So I would hope, that I've persuaded at least some of you that the ontologization process is richer than the current practice would suggest, and that there's two-dimensional perspectives give you a way to try and assess, if you like, where the opportunities are, where you are, where you could go. So looking at generality, looking at digitalization. And if you want an example, I think, in a sense, if you're trying to claim this is impossible, it can't be done, bCLEARer provides an example of it. At some other point, or if you want to, you can look at this paper here. You can see the context. Okay, thanks, Frank.